Here is the third pattern from the Gang of Four. This one is called factory method pattern, and it is a pattern you use when creating new objects. Here's a quick summary of what we're trying to accomplish with this pattern. The factory method pattern is a good choice when you are trying to accomplish the following. You want to define an interface for creating objects, but you want to let subclasses decide which class to instantiate. You want to decouple requesting objects from creating objects. The calling code doesn't need to know what types of objects are created. Okay, let's go through the points one by one. The key intent is that you want to request some kind of object. In the terminology of this pattern, we call the object a product. This design pattern gives you fine control over how the product is created. The big disadvantage of the new keyword in C# is that it does exactly what you specify. It always creates a new object of exactly the given type. This is all fine and good, but what if you sometimes need to create a subclass of the given type instead? Or maybe you want to occasionally recycle an existing object, instead of always creating a new one. This pattern gives you that flexibility. The factory method sets up an abstract object constructor that you can override in subclasses. This gives the subclass full control over object creation. The calling code simply requests a new object, and the subclass decides how to respond. And finally, the calling code must only work with abstract product classes and never need to know the exact type of the created objects. The factory class provides a creation service for the entire applications. Clients never create products directly, but instead they always ask the factory to do that for them. So, I've already mentioned two important benefits of the factory pattern. The first benefit is flexibility. The client requests an object and the factory subclass has full control over the creation process. It can return an exact instance of the requested type, but it can also return a subclass if necessary. The client basically requests a new product, and it's up to the subclass to decide if this is going to be product A, product B, or product C. The second benefit is that the subclass can also decide not to create a new object at all. There might be a perfectly fine existing object lying around that can be returned. You often see this with immutable objects. Examples are string.empty or color.red. These are both factory methods that return a pre-existing immutable object instead of creating a new one on the fly. Another benefit is code maintainability. All object construction happens in a small number of factory classes, so if you need to change the type of product objects that are created, you only need to refactor a small amount of code. Without the factory pattern, you would have to hunt through your entire codebase and track down every single new operator. These benefits are so powerful that some developers are saying that you should always use factories for all object creation in your code. Personally, though, I wouldn't go that far. if the class that's instantiated never changes, or if instantiation takes place in a virtual method that subclasses can easily override, then there's no need to use this pattern. Okay, here is the UML diagram of the factory method pattern. The diagram is fairly simple. On the left hand, we have the product hierarchy with an abstract product superclass and a concrete subclass. On the right, we have the factory classes. There's an abstract superclass factory called creator with a factory method called, well, factory method. The factory method is abstract and returns a value of type product. The method is implemented in the factory subclass, which is called concrete creator. This class overrides the factory method and explicitly returns an object of type concrete product. To use the pattern, you create a variable of type creator and initialize it with an instance of a concrete creator class. Then, when you call the factory method, it will return a concrete product. There's a very popular alternative pattern implementation, which looks like this. In this model, the factory method is actually a static method of the product class. The static method evaluates its arguments and decides what kind of product subclass to return. The static pattern is slightly more elegant than the creator pattern. Consider, in the creator pattern, the client has to specify which concrete creator to instantiate, so the client actually has limited control over the type of product object that will be returned. But in the static pattern, all creation logic is hidden away inside the static method. So now the client has zero control over the creation process. I prefer the static pattern because it is slightly less verbose than the creator pattern. I don't have to explicitly instantiate a creator before I can start creating product objects. A static method is available right away. Okay, let's look at an example of the factory method pattern. In the previous lecture, I automated a fast food restaurant that served kiddie menus that contained a small toy. So in this lecture, let's automate the factory that creates these toys. My toy factory uses a process called injection molding to create plastic toys. In this process, a special plastic powder is injected into a mold and then heated. The powder turns into plastic, and the mold determines the shape of the plastic. The toy creation process is always the same. The factory prepares a quantity of plastic powder, selects the correct mold, injects the powder, heats the mold, extracts the toy, and finally paints the toy. So I am going to implement the pattern with these classes. Okay, let's take a look at the code. I'll start with the toy class. This is my abstract product class, and it contains 3 abstract methods for creating a plastic toy. Get powder quantity, get heating time, and get color. These methods return information to customize the toy creation process. The concrete product classes are the actual toys: Fire Truck, Duck, and Superman. These classes correspond to the 3 toys that the factory is making. Each concrete class implements the getPowderQuantity, getHeatingTime, and getColor methods. You can see that the Superman toy requires 20 grams of plastic powder, needs 1 minute heating time, and is painted blue. But now look at the fire truck. It needs 40 grams of plastic powder, 2 minutes of heating time, and it's painted red. Okay, let's look at the Toy Creator class. This is my abstract factory class that specifies the toy creation process. It has a method for each step in the toy creation process: prepare powder, select mold, inject powder, heat mold, extract toy, and paint toy. Let's look at the make toy method, which automates the entire toy creation process. The method starts by creating a new toy instance by using the create toy method. And this is the factory method. It is abstract and needs to be implemented in a subclass. Next, the make toy method asks the toy how many grams of plastic powder are needed. It calls the prepare powder method to reserve this exact amount of powder. Then it selects the correct mold and injects the reserved amount of powder into the mold. It asks the toy for the heating time and then heats the mold for that specific duration. It extracts the toy and then asks the toy for the paint color, and then it paints the toy in that specific color. So the only abstract method in this entire process is create toy, and the subclasses will implement this method. So here is the Fire Truck Creator class. And you can see that it implements the create toy method by simply returning a new fire truck object. The Duck Creator class does the same, and it returns a new duck object. And finally, here is the Superman Creator, which returns a new Superman instance. The main program method is down here. It declares a variable of type toyCreator and then initializes it with an instance of a firetruck creator. Finally, it calls makeToy to create an entire firetruck. The next code fragment does the exact same thing, but this time for a Superman toy. Let me run the program to prove that everything is working. I'm compiling the code now. And now I'm running the program. And there you have it. One fire truck and one Superman. Everything works. Okay, here's a quick checklist you can use to implement the factory method pattern. First, make sure you need control over how your code creates new objects. Do you occasionally need to return a subclass? Or reuse an existing object? If not, then stick to the new operator. Next, create a concrete factory class for each type of object. Then, create an abstract factory that unifies all concrete factories. And finally, make sure the client does not use new anywhere and only uses the factory methods to create new instances. And here are some final comments. In my example, the toy creator creates a toy by calling a sequence of methods, starting with an abstract createToy method. We call this a factory method pattern. However, if any of the other methods are also virtual or abstract, then we would call this a template method pattern. And in fact, you often see the factory method pattern and the template method pattern together in the same code. The big advantage of a factory method is that it can return the same instance multiple times, in effect decoupling the act of requesting an object from the act of creating an object. And finally, you usually start out using factory methods to create objects. Then, as your code gets more and more complex, you might want to refactor to a prototype or builder pattern. This is perfectly okay. Feel free to swap one pattern for another as your code evolves. Okay, so here's a summary of what we've learned. The factory method pattern provides an interface for creating objects, but it lets subclasses decide which class to instantiate. Use this pattern if your object creation code sometimes needs to return a subclass or reuse an existing object. The factory method pattern is often seen together with the template method pattern. The calling code never instantiates objects directly and does not need to know the exact type of object being constructed. It's perfectly fine to migrate from a factory pattern to a builder or prototype pattern as your code evolves.